The diagram shows two identical bars of negligible weight. All the forces acting on the bars are marked. Which bars are in equilibrium? The first thing that you need to understand are the conditions for equilibrium. There are two conditions for equilibrium. Number one, the resultant forces on the object should equal to 0. There is another condition which is resultant moment or torque should also equal to 0 Newton meters. Now students understand this, they remember this, but they seem to forget about this condition on equilibrium as well. Now over here you have 2 newtons upwards and then 2 newtons upwards, so the total upward force is going to be 4 newtons. Similarly, you have a downward force of 4 newtons as well, hence the resultant force is 0. So sum of forces is equal to 0. For this, first condition is met. The second condition is the resultant torque should also be 0. Now over here you can see that 4 newtons is acting at the center. Okay, from here, let's say this is a distance x from the center, this is the same distance x from the center as well. This 2 Newton force is going to produce an anti-clockwise torque. This is going to produce a clockwise torque, and always remember one thing, that if a force, I'm going to write it down, if a force passes through the pivot, the torque due to that force is equal to 0 Newton meters. So over here, if I take center as the pivot, you can see that this 4 Newton force is passing through the center, so the torque due to this is going to be 0. So you have a clockwise torque of 2x and you have an anti-clockwise torque of 2x as well. Anti-clockwise is equal to clockwise, hence the resultant torque is also 0 Newton meter. So the second condition for equilibrium is also true. Now let's check bar 2. Over here you have a 2 Newton force which is acting upwards and a 2 Newton force which is acting downwards. So 2 Newton force upwards or 2 Newton force downwards, your resultant force is equal to 0 newtons. But is the torque, resultant torque, equal to 0? This is an example of couple forces. This 2 newtons is also going to produce clockwise torque. The 2 newtons acting downwards is also going to produce a clockwise torque. Hence, you have torques only in the clockwise direction. So the sum of the moments cannot equal to 0 Newton meter. Hence, only bar 1 is in equilibrium and the answer is B.